so today's video will be on trigonometry. If you're not aware, trigonometry relates to triangles. In this case, it'll be right angle triangles, and we're talking specifically about the relationship between side lengths and angles. Okay, so our learning goals. So by the end of the lesson, you'll be able to do quite a few of these things. You'll be able to label sides of a triangle, write trigonometric ratios, solve for a variable in the numerator of a trigonometric ratio, and solve for a variable in the denominator of a trigonometric ratio, and solve for unknown side lengths. Okay, so the first thing we need to look at is the names of all the sides in a triangle. So we've kind of touched on this before when we did Pythagoras' theorem, but we're going to look at it in a little bit more detail. Now, for a right angled triangle with another angle, which we label with a symbol that looks like that shows that angle. So that's like an angle that we don't have a value for. The hypotenuse is the longest side opposite the 90-degree angle. So you can see down the bottom here we have our symbol showing we have a right angle, and the one opposite that is going to be our hypotenuse. So we sometimes will just use the symbol H for hypotenuse. Okay, so the opposite side is the side that's opposite that angle. So we're given this angle here. The side that's opposite that is the opposite side, and we'll sometimes just use an O to show the opposite side. And the adjacent side, which is the one that's next to this angle but not the hypotenuse, is called adjacent, and we'll use an A to show which side that is. Okay, so we have a few ratios here that we have to remember as well. So for a right angled triangle with a given angle, the three ratios are sine, cosine, and tangent, and they're given below. So we actually just call them sin, cos, and tan. So the sine of an angle, or sin of an angle, is the length of the opposite side over the length of hypotenuse. So that's our first one here. Our second one is our cos, and that's the length of the adjacent side over the length of the hypotenuse. And the last one is tan, and that's the length of the opposite side over the length of the adjacent side. So for any right angled triangle with the same angles, those ratios will always be the same. So as long as the angles are the same, the ratios will always be the same. Even if the lengths are actually different, they'll have the same ratios. So I know that's a lot to remember, so you can actually use SOHCAHTOA to help you remember it. So SO, which is our first one, that's just sine. So sine equals OH, so opposite over hypotenuse. Our next one, which is CA, that's cos equals our adjacent over our hypotenuse. And our lucky last one, TOA, is tan, and that equals opposite over adjacent. So if you can remember SOHCAHTOA, you'll be able to remember these ratios a lot easier. Okay, so we've got a worked example here. So label the sides of the triangle as opposite to the angle is O, adjacent to the angle is A, or the hypotenuse is H. So remember, our hypotenuse is the one that's opposite that 90-degree angle. So we've got our 90-degree angle here. It's pointing at our hypotenuse, so this side will be our hypotenuse. Now, our adjacent side is the one that is adjacent to this angle, but not the hypotenuse, which is this side. And our opposite side is the side that's opposite that angle, which is that side there. So that would be that triangle labeled. Okay, so our next question says, write a trigonometric ratio in fraction form for each of the following triangles. Now, this is when we need our SOHCAHTOA. So you could write that down if you want to, and it will help us with writing our ratios. So we'll look at our first one here, which is A. So we have to figure out what sides are we given. So this is our angle here. So we can work out which is the hypotenuse, the opposite, and adjacent. So obviously this is our hypotenuse on this side, this is our adjacent, and this is our opposite. So now we've got to look, which sides are we given? Well, we're given the hypotenuse and we're given the adjacent. So then thinking about our ratios, which one relates to the hypotenuse and the adjacent? So if you look at our SOHCAHTOA, you'll see that it's cosine. So cos of the angle equals our adjacent, which is 5, over our hypotenuse, which is 7. So we'd leave it there in fraction form because that's what our question asks. For B, again, you can label the sides to help you figure it out. So this side is opposite that right angle, so that's the hypotenuse. This side is adjacent to the angle, but it's not the hypotenuse, and this one is obviously the opposite. There we go. So in this side, in B, we're given the opposite side and the hypotenuse. So think about SOHCAHTOA. Sorry, which one relates to the opposite sides and the hypotenuse? It's S, so sin is our opposite over our hypotenuse, so that's 4 over 9. And for our last one, C, again you can label the sides, hypotenuse, adjacent, opposite. This time we're given the adjacent and the opposite. Which one does that relate to? That's tan. So tan is our opposite, which is 3, over our adjacent, which is 5. So that will be our answers there for these ones. Okay, so key ideas continue. This is going to be a little bit of a longer video if you haven't figured that out. So if the angle is in degrees, the ratio for the sine, cos, and tan can accurately be found using a calculator in degree mode. Now, you should all have a calculator that looks like this one, and you can check whether it's on degree mode. So there's a button up the top here that says mode. If you click on that, the first thing that should be flashing is the degrees. You've also got radians and gradients, so make sure it's on degrees. Enter and make sure your calculator is on that, because if it's not on that setting, you won't get correct answers when you're working these out. Okay, so if the angles and one side length of a triangle, of a right angled triangle, are known, then the other side lengths can be found using the sine, cos, or tan ratios. So what does that actually mean? Well, if we look here at our worked example, let's just look at this first one here. So we are given an angle, so this time it's not unknown, it's 30 degrees. We're also given 3 as our value of our hypotenuse. This is obviously our adjacent, and this is our opposite side. But our opposite side now, we've got an x, so we want to find out what that is. So we are going to use whichever of our SOHCAHTOA, whichever of our SOHCAHTOA relates to the opposite and hypotenuse, which we know is sine. So sine of our angle equals our opposite over our hypotenuse. We can fill in what we know. So we know our angle is 30, so sine 30 equals our opposite, which is x, over our hypotenuse, which is 3. So then we can just solve for x. So obviously we're going to multiply both sides by 3. In your calculator, you would find your sine button, which is kind of here, which is next to pi. So you'd press sine, and then our angle is 30. Close our brackets, and obviously that's being multiplied by 3. And then you'll be able to get your answer there. So we're going to round to 2 decimal places when we do this. So you're just going to put your answer to 2 decimal places. So for our second example here, we have got our hypotenuse, our adjacent, and our opposite side. This time we're looking at hypotenuse and adjacent, which you know is cos. So the cos of our angle, which is 42, so cos 42 equals our adjacent side, which is x, over our hypotenuse, which is 7.2. We can then solve for x. Our last one, we are given our angle here, which is 71. This time we're given our adjacent and our opposite, and we can use tan. So tan of that angle, which is 71, equals our opposite side, which is x, over our adjacent side, which is 4. We can solve for x by doing 4 times tan 71. Okay, hopefully that makes sense for you there. Okay, so we've got some worked examples here. So I have to evaluate the following using calculator, rounding to 2 decimal places. So the first one is sine 50. So you find that sine button on your calculator, which is this one here. You go sine 50, close bracket, press enter. You'll get a very long decimal number there. I don't know if you can read that through my camera, maybe. And we're going to round that to 2 decimal places. So the answer is 0.76604, etc., etc. So we're going to round to 2 decimal places. So that will equal 0.77 when we're rounding to 2 decimal places. For our second one, we've got cos, which is next to sine on your calculator, which is here. So you're going to press in cos, and it's 16. Close brackets, enter. Again, you've got a very long decimal there. We're going to round to 2 decimal places. So that's 0.96126, and we're going to round that to 2 decimal places. So 0.96, the next number is 1, so it's just going to say it's 96. And the last one is tan 77 degrees. So tan right there next to our division sign. So we're going to put tan, type in our angle, which was 77, close brackets, enter. And that one is 4.33147, etc. So we'll round that. 4.331 rounds to 4.33. And that would be our answer for that one. Okay, so for D, find the value of x in the equation cos 20 equals x over 3. Now, we need to solve for x, so we know that cos 20 equals x over 3. So to get rid of that 3, we're going to multiply both sides by 3. So it'll be 3 times cos 20, that's a degree sign, also not a 0, equals x. So x will equal, so in our calculator, 3 times cos 20, close brackets, equals 2.8190. So we're going to, etc. So we're going to round to 2 decimal places. So 2.819 will round to 2.82. 82. There we go. Okay, so two more worked examples. So for each triangle, find the value of x, correct to 2 decimal places. So looking at our triangle, you can label the sides if you want to. Remembering, so, ka, toa. Obviously, you won't have to write this out every time if you start to remember it. I'm just writing it out just so you're reminded of it. So you can label the sides. Again, you won't have to do this every time. It's just so that, I can show you the process. So this side here, hypotenuse, because it's opposite this 90-degree angle. This side here is adjacent to our angle, and this one will be our opposite side. So we've got x here, we've got 7, and we've got an angle. So we're dealing with the opposite side and the hypotenuse, so we know we're using sine. So sine of our angle 38, so sine 38 is x over 7. So to solve for x, we're going to multiply both sides by 7, so x is 7 times sine 38, which we can type into our calculator, so 7 times sin 38, close brackets, enter. So 4.309, so we're going to round 4.309 to 2 decimal places, which is 4.31. 4.31. So x equals 4.31. For our second example, we've got our hypotenuse here, we've got our opposite side and our adjacent side. We're dealing with our opposite and our adjacent, so obviously we're using tan. So tan of our angle, which was 42, just rub that out, 42, not 4. So tan 42 is equal to x over 4. So x equals 4 times tan 42. In your calculator, you can type that in, 4 times tan 42, close brackets, enter. 3.601, so we're rounding to 2 decimal places, so x equals 3.601, so that will be rounded to 3.60. That would be our answer for that one there. Oh, I should label my questions. This is A and this is B. Okay, so key ideas continued. So if the unknown value of a trigonometric ratio is the denominator, you need to rearrange the equation to make the pronumeral the subject. So for the triangle shown, remember we've got so, ka, toa, and we'll label our sides here. Okay, so we're dealing with the hypotenuse and the adjacent side. So we know that's using cos. So cos 30, which is our angle, equals our hypotenuse 5 over our adjacent side, which is x. So we have to rearrange this to solve for x. So we can multiply both sides here. So x of cos 30 degrees will equal 5. So we're going to rearrange that again because obviously we can't type in x times cos 30 because we don't know what that is. So we're going to divide both sides by cos 30. So x will equal 5 over cos 30 degrees. So you can type that into your calculator. So 5 divided by cos 30 degrees, and we are going to round that to 2 decimal places, which will be rounded to 2.44, and that will be our answer there. Okay, so we've got 2 worked examples, so find the values of the pronumerals correct to 2 decimal places. So we'll start with A. Again, we can write down our so, ka, toa, and label the sides of our triangles. So this is our hypotenuse, adjacent, opposite, hypotenuse, adjacent, opposite. So we'll deal with A first. So A, obviously we're dealing with our hypotenuse and our opposite. So if we look at our ratios, so that's sine. So sine 35 degrees is equal to our opposite, which is 5, of our hypotenuse, which is x. So we're going to rearrange that. So x sine 35 equals 5. So x equals 5 divided by, that should be sine 35. So we can type that into our calculator. So 5 divided by sine 35, and that leaves us with an answer of 8.717, which we're going to round to 2 decimal places, which is 8.72. Now, for B, it's actually a little bit more complex. So I'm actually going to clear this so I've got a little bit more space. So I'll clear the screen there. Toa, label our sides again. Okay, so for this one, we have a few different variables here. So we've actually got 2 unknowns and only one side is known. So from here, there's a few ways you could approach this. So obviously we're going to have to use the O, so the opposite, because that's what we've got a value for. So we can either use sine or we can use tan. So I'm just going to use tan to solve for x first. So tan 28 degrees is going to be our opposite side, 19, over our adjacent side, which is x, which we can change to x. Tan 28 equals 19. That should be x here. So then x will equal 19 over tan 28 degrees. That is atrocious writing. Let me clear that up. So that's 28. There we go. Okay, so we can type that into our calculator. So 19 divided by tan 28. That equals 35.733. So we'll round that to 35.73. So that will be this side here. Now, we can actually use Pythagoras' theorem to solve. So c squared equals a squared plus b squared. And we can actually fill those in. So our hypotenuse there, so c squared will be equal to 35.73 squared plus 19 squared. So 35.73 squared plus 19 squared. Okay, so c squared is equal to 1637.6329, so I'll just round that again, 0.63. So there, to find c, we're going to do the square root of 1637.63. So c, which is our hypotenuse, will be that. So square root of 1637.63 is 40.467, round that up, 40.47. So then we'll have our values of both of our unknowns there. So therefore, x equals 35.73 and y equals 40.47. Okay, so that's all we have for today's video. Any questions at all, please come and see me in class.